Example 3, find the general indefinite integral. So the one thing you want to notice here, it's an indefinite integral because we do not have a lower and upper limit. So let's go ahead and simplify this. So we have the integral of 10x to the fourth minus 2 secant squared x, and that's dx. And so now we're going to use our properties of our integrals. So this is subtraction, so we can now expand this with two integrals. So we're going to have the integral of 10x to the fourth, but we have to include the dx, minus, again, the integral of 2 secant squared x, and again, we have to include the dx. Okay, now we have a constant that we can factor out. So we can factor out the 10. So this is 10 times the integral of x to the fourth dx, minus we can factor out the 2 of the integral of secant squared x dx. Okay, now what we want to do is we want to find the antiderivative of x to the fourth and the antiderivative of secant squared x. Okay, so by doing so, we're going to have 10 times the antiderivative of x to the fourth is x to the fifth over 5 minus 2 times the antiderivative of secant squared x is the tangent of x. And then again, when we're taking the antiderivative of an indefinite integral without the upper and lower limits, we need to make sure that we include the constant c. So now let's just simplify this a little further. If we take 10 and divide that by 5, this is going to give us 2x to the fifth minus 2 times the tangent of x plus c. Okay, so now we have the antiderivative of the function. Okay, now let's just take a look at this graph. Well, if we take a look at this graph, this indefinite integral in this example is graphed in the figure above for several values of the function c. Okay, because the value of c can be any value, right? So here, the value of c is the y-intercept, so where it's crossing the y-axis.